Welcome friends. So in this one I'm going to show you several examples of differentiating expressions of the form e raised to some exponent, okay? The exponent can be a different kind of expression. So let's go with the first example here. Maybe it says like, let's say the derivative with respect to x of e to the x squared. So pretty common thing. Let's go to the process. So what do? Well, by the chain rule you keep the e to the x squared part. So you just copy that directly, completely unchanged, unaltered, okay? I'm going to write down, actually, I'll have more room this way. So it's going to be e to the x squared. But then you have to multiply by the derivative of the inside, which is x squared, because here when you plug a particular value of x in, first you square it, second you exponentiate. So you're going to have to multiply then by the derivative with respect to x. It's meant to be a d of x squared. And then you work through this. So this is e to the x squared. And now this becomes 2x by the power rule for derivatives, you see. And lastly, by convention, the 2x goes out front. Therefore, we just end up with, let's see, 2x multiplying e to the x squared. And that is the answer in this context. That's all. All right, let's take a look at another example. Let's vary it a little bit. So let me draw a line here, a divider line. Good, so make one up. So for example, the derivative with respect to x. All right, let's do here e. And now make this sign up here like this, and then x this way. So now we have a combination of e and the sine function. So how does this operate? You apply the same principle. So the principle states whatever this is, it just gets copied straight down in that form unchanged. So you're going to have e raised to the sine of x like this. All right. And then you multiply by the derivative of the sine of x, which is the derivative of the inside. So the derivative here, let's see, with respect to x of sine of x this way. Now, once you have it in this form, then you just finish it up. All right, so the first part is just e to the sine of x. That stays. It's just e to the sine of x this way. But this second part, that sine of x differentiates to give you a cosine of x this way. Okay, so cosine of x. And then the convention is to place the cosine out front or not. You can leave it either way. That's trivial. If you like, you can write it then as, let's see, cosine of x multiplying e to the sine of x, if you like. That works. Okay, let's do another example here. Let me draw a separated line this way. And for the last one, let's do one that looks like the following here. So e raised to the square root of x. Again, here you have the square root function. So when you differentiate, you have to keep that in mind because that's your inside. And the e is the outside. So remember, what we are doing to this is we are hitting it with the derivative operator this way. Okay, so let me write across because I want to make sure I have enough room here. So it's going to be the following. This part gets copied as always. So it just becomes e raised to the root of x. And then you multiply by the derivative of the root of x this way. Now the level of detail that you choose to show here is entirely up to you. Some people know the root of x differentiated inside out already. They've done it so many times. But let's see. We can say the following. It's going to be e to the root of x. And if you wanted to be very careful, you would differentiate here with respect to x. And this is equivalent to x to the 1/2, you see? In case you've forgotten. That's the exponential form of the root symbol. So now you're going to have e to the root of x. And by the power rule on this part, you're going to bring the 1/2 down like this. You're going to do x. And then from the 1/2, you're going to subtract 1. So you're going to have 1/2 minus 1 all the way up there, you see? So it's e to the square root of x times 1/2 x raised to the 1/2 minus 1. All right, and then you finish it up. So it's going to be here e to the root of x times 1/2. That's going to be here x. Now 1/2 minus 1, hopefully you know that is. Maybe I can squeeze that in somewhere. Let's see. I'll put that in here as a reminder. So let me block this off a little bit right here. I'm going to do 1/2 minus 1. You should be able to see it there. So it's going to be 1/2 minus 1, which is 1/2 minus 2/2, which is negative 1/2 right here. Negative 1/2. So now coming back to here, it's going to be, let's see, x raised to the negative 1/2 right here, negative 1/2. That's a negative there. So negative 1/2. Now you just rewrite this. Well, how do we rewrite it? So you're going to have e raised to the square root of x. Keep the 1/2. And because this is a negative 1/2, at first it will go to the bottom as x raised to the positive 1/2, this way. So I'm putting this negative exponent in the bottom as a positive 1/2. And then you continue with this process, okay? So this one is way longer than the other ones, as you can see. So e to the root of x, and then the 1/2, and then it becomes here in the bottom, because it's x to the 1/2. 1/2 is the exponential form of the square root symbol, so it becomes the square root of x this way. And there you go, that's the answer, e to the root of x times 1 over 2, the root of x again. If you like, you can write this more compactly in its final form as e to the root of x, because e to the root of x times 1 is e to the root of x. And you can keep that 2 root x in the bottom in that form, right there. And that basically does all of the steps in great detail, I think. This is all of the work. Thank you so much for watching. I hope it's been helpful. Please remember to subscribe, to like, to share. I'll see you in another video.